to all of you. So today we will be studying about the risk part. Okay. So in the first week we have discussed the threat and vulnerability part, and in this particular lecture we will discuss about the risk and how to calculate the risk and how to mitigate, means how to reduce the risk whenever you are designing any kind of a software. Okay. So the main task of a penetration tester or any kind of a software engineer is to decrease the risk, uh, to decrease the security risk that can arise in a particular software. Okay. So previously we have studied about that there are four main principles of security engineering. That is, there should be a considerable policy. Then there should be a mechanism, the tools to implement that policy, and then there is a assurance. So assurance means that we are 100% certain that these software tools to implement the policies work 100% of the time. Right? And the last one is incentivization, means that you have to train people, you have to incentivize people by giving them proper salaries to in order to properly implement those tools. Okay, so these are the four main principles of a security engineering framework. Okay, so if you are implementing these four principles very strictly, most of the time many of the vulnerabilities that can exist in a system can already be can be easily vanished. Okay, so there will be very less vulnerability if you're able to implement these four principles in a particular software or in a particular program or in a particular website. Okay, so again, there is something called cryptography. So I'll give you a little bit of introduction about the cryptography after the risk part, because there are some certain terms that I will be using, like public key cryptography, symmetric key, shared key. These are the things that I will be using. So I have to explain you what are those particular terms are. Okay. Going into the risk part, we have studied about what is a threat and what is a vulnerability. So threat can be easily diagnosed by antivirus software and vulnerability can easily be diagnosed by a penetration tester. Okay. So what is risk actually? So risk, the main objective of a security engineer is to reduce the risk, mitigate risk. Okay. So I'm stressing this enough that it does not mean that you can eliminate all the risk 100%. There will be a little bit of a risk still be there, but again, I'm saying it that you can only reduce the risk, but you cannot eliminate them completely. Okay. So the main task of a software engineer is to mitigate the risk. It means that you can reduce them to an acceptable level. Okay. Another thing is that you will to make sure that your security controls are effectively controlling the risk in your environment. You need to anticipate what kind of incidents may occur. Okay. So risk assessment is the step in security engineering where you assess all the particular assess the situation. Okay, so you can assess that there can be a particular security risk that can exist in a system. Okay, so there is a proper framework for that, there are proper commands for that you will be checking for the most general risk in a particular software. Okay, so there is no kind of a mechanism there. You can look at a software and you can easily go through the literature to find out the common risk that can arise. Okay, so if there are certain ports that are being opened whenever you're running a software, you just have to close those ports. Okay, so this comes under risk assessment. Okay, another thing is that you have to identify what you are trying to protect and from whom. These are some of the frameworks that can arise from that. These are the main steps that you can whenever you are assessing risk that you have to keep in mind. Another thing is that you have to evaluate the threats that can be converted into a risk. Okay, so evaluating threat is an important part of a risk analysis. Suppose there is any kind of a software that there is any kind of a virus that came into your system and the antivirus is not able to detect it. So that particular threat is now converted into a risk to your system. Okay, so again, you have to access that part also, that if a user is unknowingly allowing any kind of a malicious software to enter into the system, then what are the steps there? Okay, so again, in risk assessment part, you will be only listing out all the possible ways that a particular system can be compromised, and you will be given a particular action plan for this as well. Okay, so these are the main things. I'll show you a little bit of examples. What can be the risk? Mostly it will be malicious software, viruses, that the things that we have already studied. Okay, so from threats, risk can easily be created. Okay, threats can take many forms. In order to be successful, a security strategy must be comprehensive enough to manage the most significant threats. Again, I'm stressing about the threat part. Okay, not vulnerability. Most of the time, the risk may arise from threats, because vulnerability, again, you have to particularly scan it. You have to get the help of a penetration tester, but risks are already being detected, and there is ample amount of literature that is being already available to you. And from a particular threat, how can a risk be arise? This is again already given to us, already available to us. Okay, so there are many ways a particular threat can convert or compromise your system. Okay, so these are some of the points that you have to keep in mind. Keep that in mind, that a risk assessment is again a part of a security engineering process. Okay, so most of the time your risk will be will get activated from the threats. Okay, risk and threat are very much interrelated to each other. Okay, again, this is not like that you are only assessing the risk, you also have to plan a particular action plan. Okay, so the task of a security engineer is to be much more comprehensive and have to write a report that these are the particular risk I find that can arise from these threats. Okay, so you have to write a comprehensive report, and you have to write a action mechanism in order to deal with that also. Okay, another thing is that security professional knows that many real world threats came mostly from inside the organization. Okay, so this is the main important thing. So mostly if the firewalls are already placed outside, and there are many security mechanisms that are implemented on a basic level, but most of the time you cannot deal with the threats that arise from inside the organization. Okay, so that is why I'm saying that you have to be physically present inside the organization, or you have to be physically present, physically in contact with the server. Okay, so it's very difficult to penetrate the server from outside. If you have a physical contact with the server, it becomes very easy in order to get inside the server. Okay, so that is why security, not only the software security is important, but the hardware security is also important. Like, you have to place external guards, and you have to take help from people. You have to put your servers inside security locks, so that many of the it is not easily accessible to external people or external sources. Okay, so that is the main important thing. So most of the time your threat will not be like some software threat. Most of the time the server's security is so much advanced, it is next to impossible to penetrate those servers. But if you are able to penetrate the security, physical security, you can easily get inside a server. Okay, so this is one most important thing. Okay, so these are some points that is related to it, that regardless of a breakdown for your particular organization, you need to make sure that your security control focus on the right threats, and to avoid overlooking important threat resources, you need to consider all type of threats. So these are some framework that you have to keep in mind. So some of the important threats are listed there. Mostly we have studied about. Okay, so you have seen manual attacks that you have to physically get into the building and get inside the server. Types of attack we can find, like viruses, uh, viruses, worms, computer worms. All of these comes under types of attack, threat sources and threat targets. Okay, so we're seeing here how can you establish security controls. Okay, so we're seeing here physically you can lock. This is a preventive measure. You can physically lock the servers wherever it is present there. For technicality, you can install firewalls and intrusion prevention system. Okay, So this is again a piece of software that cannot let anybody inside a particular system. If you are even this intrusion prevention software will come into it, and it can again block all the scanning protocols that is used to scan a particular system. Okay. Another thing is operational. You can place a guards on the station. Virtual, you can write a dynamic access list. In the similar way, there are 5 types of security controls. For 5 types: secure, preventative, uh, detective, deterrent, corrective, recovery, and compensative. Okay, so most of these security protocols, and again, these are security protocols. If you're seeing here, every security protocol is from a different perspective. Okay, so you have to install physical cameras here. You can install an intrusion detection system, and then there will be a login, and then there will be SIEM, then there will be guards patrolling. So these are some of the security controls that you can install. Again, these are not, you can say 100%, it will always be 100% proof, but still it will be able to reduce the risk, or reduce the chances for any kind of a compromise of a system around 70 to 80%. Okay, so these are the most implemented security controls. These are general security controls that you can find. Okay, some operational, like this particular thing is very, very important, that is disaster recovery plans. Okay, sometimes what happens is that due to some earthquake or any other natural disaster, suppose that there is a fire in a building, most of data on the server are being lost. Okay, so in order to recover those particular server data, there are already a disaster recovery plans that will be there. So these are like a backup to the server, such that we can obtain all the previous information that is being stored in the server. Okay, so this is very, very important, and most of the server do this kind of a thing, always do this kind of a thing, and it comes under operational. Okay, you just read about it in the PPT. I'll I'll list out these are various kinds of attacks that are being here. So these are some security controls, you can read about it. The thing is that how to analyze a risk. Okay, so risk analysis is a very important task. You have to analyze by using this formula, that is probability of any kind of a threat, and this is also referred to as a incident. Okay, so if you are able to if you are able to get the probability that a particular threat exists in your system, and how can you exploit a particular vulnerability in the system, then the risk can be calculated, and you can also multiply it by the cost of asset damage. So this is referred to as a impact. Okay, so how much system is impacted by this, how much system can be impacted, like if it is impacted 90%, then it will be 90% cost of asset damage, and something like this. Okay, so the risk can be easily calculated by calculating the probability. Probability means that you are probable that a particular is being threat can be arise in the system, that you can list it out. Again, the probability can easily be calculated. Firstly, if you are able to eliminate all the general threats, and then you can list out some of the threats that is particular to that particular system. Okay, so again, that is a particular formula for calculating a risk part. Okay, another thing is that how can you calculate an analyzed loss. Okay, so what it means is that how much loss can you face if you are for 5 years. Okay, suppose I'm saying due to some of the threats, how much particularly loss I'm facing. Okay, how can you face a loss if your server is not online? Then there will be particular requests there that you will not be able to process. Okay, so what it means is that if you are not able to process those requests, maybe it will be a monetary loss to the organization. Okay, so this particular thing comes under analyzed loss. Okay, so for 10 years, suppose you have faced single loss and analyzed loss rate. Okay, so I'll tell you about it. So if there is an example, one commonly used term assigning to cost to risk is analyzed loss expectancy. This is the cost of undesired event, single loss expectancy. Okay, so this is again that any threat or any risk can arise, and what is the a rate, analyzed rate, that is multiplied by the number of times you expect that event to occur in 1 year. Okay, so that is referred to as the analyzed rate of occurrence, ARO. Okay, so if you see here, if I take this example, suppose you don't really have to say that your web server will be defaced once every 5 years. Okay, so once every 5 years means that it once every 5 years. Okay, so now your analyzed loss will be calculated for 5 years here. Now if you calculate it, if it is your web server does not work once every 5 years, so the ARO, the analyzed rate of occurrence become zero point 0.2. Okay, so it is 1 by 5, so it will be 0.2. Okay, so thus this ARO will becomes 0.2, and the cost of rebuilding it. Okay, so again we are calculating the cost here, that will be your loss. Okay, so it along with the reputation damage that occur will be 10,000. Okay, so it means every year you have to pay 2,000 rupees for 5 years, that will be 10,000. Okay, so again analyzed rate cannot be say, you cannot say that it is for 1 year. It can be calculated for 5 years, it can be calculated for 10 years also. Okay, so you're seeing here uh, that the analyzed loss is very much higher, then you have to again hire and recalculate the threat analysis, and you have to recalculate everything such that your analyzed loss will be less. Okay, so again, rather than, if you're seeing here, if your risk assessment that you have done in the first step, if the probability of risk is very less, this one these things are calculated on real values, and these things are calculated on expected values. Okay, so you are thinking that there can be the risk percentage and the cost of damage that can occur will be around $500. Okay, so this particular thing will depend upon the probability of a threat and the exploit of the vulnerability. Okay, so if you have done this particular thing very correctly, your cost of damage will be very less. Okay, so again, if you're seeing here, the main particular source of your loss is the probability of threat and exploit of vulnerability. So that is referred to as incident. So we do not want, we always want that the probability of the risk should be less. The probability of the threat should be less. If the probability of the threat should be it is less, the risk part will also be very less. Okay, so similarly, if you're seeing here going forward, these are actual figures. Okay, so these the upward risk is an expected figure. Suppose I can give you expected that there will be $500 loss for 1 year, and this is actual figure that you will get, how much single loss is being done, how much analyzed rate is being there. So you can calculate it easily by seeing the performance of a system for 1 year, for 2 year, for 3 year, and then you can compare it with this one. Okay, so if the risk was very less, the your analyzed loss will also be very less, but if the risk is very high, your analyzed loss will also be very high. Okay, so again, these are actual figures, like these will be actual loss that you are facing. Keep that in mind. This is just a theoretical value, and this is just a expected loss. This is just, the risk is just a expected loss, and analyzed loss is particularly the actual loss that you will face. Okay, so these are some values that is related to it, and there are some method of defense that are being there. You can easily use these particular methods in order to avoid any kind of risk that can arise. Okay, so there are ways to deal with risk. First is prevent, then there is deter, then there is deflect, detect, and then there is recover. Okay, so just wait for a second, wait 1 minute. Just wait 1 second. Just wait 1 minute. Wait 1 second. Okay, sorry for that. Now, coming towards the same thing, that how can you do a little bit of a defense of these things. So first one is prevent. So there are already security controls that I have told you. So you can again prevent something from happening by just installing any kind of a physical system logs that you can do, and other things that can happen. So this prevention is that you avoid any kind of a risk or any kind of a threat before happening. Okay, so for that you can place any kind of external prevention there. You can place a lock towards the server. You can again there will be intrusion detected attacks. You can place a firewall here, so that will also come under prevention. So there will be already a firewall, that is a software tool, and that will prevent any kind of attack from happening. Okay, another thing is deter. So deter will be that you can deter means that to discourage. Okay, so how can you discourage anything from happening is that if anybody is trying to attack, you can uh, you can just install any kind of a software system to discourage it. Okay, suppose uh, a particular attacker is trying to attack this system. Okay, B. It is trying to attack this particular system. But what I'm doing is that how can I discourage this from attacking is that I can check this particular, I can easily install an intrusion detection system here, IDS. I can install an intrusion detection system here. And I can say that rather than detection, I can install intrusion prevention system here. Okay. So when I see a particular packet arising from a particular host, suppose this is a host and I'm saying that this is a third party host and it is trying to scan the ports. Okay, suppose it is writing a command like nmap. It want to scan my TCP port, so I'm writing st. Okay, so whatever is the IP address of this particular machine. Okay, so this whenever this particular host is trying to scan the port of this target server, that is B, IP address of B. Now the intrusion prevention system is easily able to detect that intrusion prevention system can see that a particular host is trying to scan my open ports. Okay, so this particular computer open ports, and it can directly close all the ports where it is where the scan is being happening. Okay, so most of probably it will be first 1,000 scan most common ports, first 1,000 most common ports, and intrusion prevention system can directly close those ports in order to get this host particularly preventing this host to get into the system. Okay, so how can this host get into the system if there is any open port? If intrusion prevention system just close all the ports, this particular host will not be get into the system. Okay, so this is how you can discourage any kind particular kind of a host coming into your system. Okay, another thing is deflect. Okay, so you can again put a honeypot server here. Suppose if you see here, this is referred to as a honeypot. So you can place a false server. Okay, so your actual server is there, but you're placing a false server, fooling the attacker into thinking that the particular attacker has gained the access of a server. Okay, so that is referred to as a honeypot server. You can place it in your environment such that the attacker think, and whatever attacks it tries to do on this particular honeypot server will be contained in this server, so it cannot go beyond that. So again, this is the advantage of deflect here. And then there is a detectives intrusion detection system. There is a prevention system and there is a detection system. Okay, so detection system is being there to easily detect any kind of attack. So if anybody is because there is a prevention system already there, so the detection system activate first, that it is detecting any kind of particular scan that is being done on an external system, and then the intrusion prevention system become active to close all the ports and something like this, so that any kind of host that is placed externally cannot be able to get the access of a system. Okay, another thing is recovery. So recovery, I have already told you that if in case of any kind of a natural disaster, okay, in case of any kind of a natural disaster, we have to have some recovery plan in our system. Okay, so that comes under recovery. So there are some backup softwares there where you can put your put all the data and you just timely do all kind of backing up to the cloud. These kind of things come under recovery. Okay. So again, this is one of the main risk, that part, that if anybody is able to get into your system and it is able to delete the data, delete your all the data that is present on a server, that particular company will be bankrupt. Okay. So the user data should not be deleted from the company server. If it happens, then again the company has to disclose that it has lost all the user information, and it will again say you to set up a new account. Okay, so if that happens, that means that you lose trust on the company, and then you will never get on a particular company website. Okay, so that is why the recovery part is always there, in order if anybody is able to get, or if any natural disaster happens within a company, there is already a backup server there that is being connected to the cloud or anything. There may be any backup, any number of backup server. There will be RAID drives that is being connected to that. So if there is any loss in a particular company server, that particular information is backed up, and you can easily upload the information by setting up a new server. Okay, so there can be a little bit delay in your in setting up the service, but still all of the client data will be in the organization. It is not going any way outside. Okay. So the prevention system makes sure that if anybody is able to enter into the system, he's not able to get out of the system. Okay, so it will remain in the system, and the information that is being there on the server will never be able to get outside of this. Okay, this is, I'll tell you about the prevention system, and there are also some experiments that is related to it. Okay, so there are some federal security standards, and this is referred to as some publications. So these are special publications that are federal standard. You can look into it. These are just theory part. Okay, so they are setting up some standards here. So most important standard is this one, guide for conducting risk assessment. Okay, so most of the testing engineers follow this particular assessment. This follow a particular standard, this particular standard SP 830, and there are many standards that are being linked there. Okay, so you can read the name of the standard, and there is specific NIST framework here, and there is some security control families. Okay, so what it means is that the there are some of the families that are being listed here. These are the things that you have to keep in mind whenever you are whenever you are testing a software. Okay, so there will be access control, there will be awareness and training, audit and accountability, configuration management. All of these are a checklist uh, whenever you are examining or verifying a particular software. Okay, similarly there is some risk management framework that exists. So this is the starting point, that you have to categorize the information system. Then you have to select the security controls. Security controls I have already tell you in the third PPT. And then there you have to implement those security controls. Okay, so these are some basic steps that you have to do for accessing the risk. Okay, so this is risk management framework. This is again provided by NIST. Again, this is a standard set authority like ISO. This is again a standard authority that standardize those frameworks. Okay, so this is referred to as security life cycle. Then you can implement security controls. You can again access if there is any problem there in the security controls, and then you can again authorize the information system, and you can monitor the security state of. So these particular things just go on for 4 and 5 cycles, such that you can easily able to get the reading that if there is any kind of a security risk involved in this. Okay, so this is regarding uh, the risk assessment part and risk management framework. So NIST is referred to as National Institute of Standard and Technology. Okay, so National Institute of Standard and Technology. Just to keep in mind that these are some of the important standard that I've listed here and that are being used right now also. Okay, so just keep in mind these standards. You do not need to worry. You do not need to read that in detail. Just remember these are some standard. You just have to remember 1 or 2 standards there. Okay, so I'll come to it whenever we are conducting an experiment, that when we try to get into a particular system where the intrusion prevention system will get activated and it can close all the ports. That can happen on many of the servers. Okay, so now moving on to now interesting topic, that is crypto. Okay. So I'll tell you a little bit of the terms of the cryptography. Till here we have, if you seen here, we have done the part, we have done threats, then vulnerability, then principle of security engineering, and then we have done the risk part, risk assessment part. Okay, so there is not much to the risk. So just risk, the part of the risk that you have to remember is that a risk can arise from threats. Most of the time risk can arise from threats and some vulnerabilities. Most of the time it will be threats, but there are also vulnerabilities that can lie in the system that can contribute to risk. Okay, keep that in mind. Okay, so now another thing is that how to calculate the risk. If you are there are some security controls that are there so that you can reduce the risk. And how can you calculate the risk? By taking the probability and you are multiplying that probability of any kind of a threat or a vulnerability arising into the cost of asset damage. Okay, so it means that if any kind of a risk happens, how much loss will you face? Okay, so that will be your risk. Again, it is an expected thing. Okay, so you're expecting that the probability that you have tested everything and the probability of threat and risk will be this. Okay, if the probability of threat and vulnerability will be less, the risk will also be less. And how to calculate the analyzed loss? This is again, this is a expected value and this is the actual value that you are seeing as loss throughout us 3 years, 2 years, 1 year. Unit you can decide. Okay, so it can either be of 1 year, 2 year, 3 year, 4 year, 5 year. That can depend upon it. Okay, so we are finding it that at 5 years you are facing around $10,000 of loss, then you can again contact a security engineer to reduce the number of risk that can arise. Okay, so most of the time if a security engineer has done a risk analysis part, the analyzed loss will be very less. Most of the time it will be less than $100 or less than $200, because the loss will only arise if the server is not available. Okay, so right now if you see here, any risk and a threat part can disable your disable the services of a server. Okay, so if any security engineer is already calculated and placed the safeguards against the common attack, then you can easily say that your analyzed loss will be very less. Okay, so close to 110, $100, $200, not more than that. Okay, so again, if this is the main thing that most of the system do not do. Okay, so most of the time if you are building a software, the companies do not consult any security engineer. Okay, so this is the main particular loss. Okay, so they trust their software engineer who have built a particular software, and that they are not aware of any kind of a study, any kind of a vulnerability or a threat that can arise in a system. That can only be known by a security engineer. So that is why the big companies face loss. And security engineer is not that it can implement high grade security. It just check the server against common attacks and place the safeguard against it. Okay, you're seeing here most of the industries do not hire a basic security engineer that can implement a basic security. Okay, so basic security features, if you implement just basic security features, 60-70% of the attacks are being disabled. Okay, so this is a hard truth in nowadays. Okay, so that is why there is a demand for security engineers. If you are able to implement basic security protocols also, you will be saving thousands of dollars to a particular company. Okay, so these are some things, and you have, in the end, you have to remember some of the standards there. So I'm just listed this standard. Just keep that in mind. There is no need to remember any of it because these are standards that are already being there. So there is nothing much to it. You just have to remember a little bit that these are standards that exist. Okay. So when you will study in deep with each and every standard in penetration testing, you will understand everything. Okay, so guide for conducting risk assessment. When you get into this, when you get into penetration testing, you will study the standard. You will understand each and every assessment methodology and assessment uh, metrics. Then you will understand the standard. Okay, so what is the meaning of the standard? It's just for the time being, just remember these particular standard, and just security control families, just remember these. Okay, moving on to the cryptography part, because we will then move on to little bit of digital signature and these kinds of things. So I have to give you a little bit of introduction to the cryptography part. Okay, so just let me discuss it. Any doubt till here, just let me know. So three topics can be covered. uh, any doubt till here?
No, sir.
So keep that in mind, it's very easy. Most of the part is theoretical that we have studied. Don't worry, it will be converted into practical part. You have studying about threats and vulnerability. When you scan it with the help of softwares, then you will actually understand that what actually is threat and what actually is vulnerability. For the time being, just we will be just keep that in mind, what is the definition of it and what are the security principles related to it. Okay, so then we will move on with it. Okay, some of the terms that will occur in the coming lectures will be a part of cryptography. Okay, so I am just listing out some of the terms that you will study, so just to clear some basics so that you will not get confused when I use those terms. Okay, so cryptography is a very basic term. There is something called a plain text. When you convert plain text to a ciphertext, and ciphertext to a plain text. Okay, so plain text is just whenever you are writing ABC, and ciphertext is that is not understandable, like uh, dollar comma, or you are changing the changing the order of these letters. Okay, so if you are writing ABC, suppose I am converting this to cipher set, this is like CBA. Okay, so it is like that you are changing the plain text such that if anybody is eavesdropping means that if there are two particular system A and B, and A is sending a message towards it, if a particular system eavesdrop, okay, eavesdrop means that it is listening to your conversation, and if try to open the message, if you are writing everything in plain text, it will this particular person C will also be able to understand whatever you are sending towards the B. Okay, so ciphertext, when you are changing the plain text into something that is not understandable to the eavesdropper, then you can say that it's a ciphertext. Okay, so this process of conversion from plain text to ciphertext, it is referred to as encryption. And then whenever it reaches towards B, it will take that ciphertext and convert it into plain text to read. Okay, so this process of ciphertext conversion to plain text conversion is referred to as decryption. Okay, so the process of encryption and decryption is referred to as the study of encryption and decryption standard is known as cryptography. Okay, it's as simple as that. So what is encryption? Plain text to ciphertext. What is decryption? Ciphertext to plain text. Okay, so I can give you easily example of some plain text. Suppose I am Ram. This is plain text, but you're changing this to an unreadable form. Okay, suppose I'm changing this to A, B, C, D, E, F. Okay, that thing, and I'm transferring to any other person. So this is referred to as a ciphertext. Okay, so there may be a key that will be present there in order to convert the ciphertext to plain text. So there will always be a key that will be there. Okay, so you're changing this to ciphertext, but you have to know that there is any kind of a key exist there that can change any plain text into ciphertext. Okay, so cryptography is of only two types. The first type is referred to as symmetric key cryptography, or it is also referred to as shared key cryptography, or it is also referred to as secret key cryptography, or it is also referred to as private key. So don't confuse these names because many exams just use these names to confuse people. So all of the name are very one. Okay, symmetric means there will be only one key. That can also be referred to as a shared key. That can also be referred to as a secret key. That can also be referred to as a private key. Okay. Another thing is asymmetric. In asymmetric, it is also referred to as public key, private key cryptography, public key, private key cryptography, or simply public key. Okay, so this is also another name of asymmetric cryptography. Okay, just keep that names in mind because most of the time they change the name so to confuse students. Okay. So what actually it is, how it works, what is the mechanism of it, I will discuss in the next lecture. Don't worry. This is a little bit interesting topic because there will be some kind of a numerical and there will be some problems that you can understand here. So just remember to attend the next one. Okay. So any doubt till now? Okay. Go ahead. You can move on to the next lecture.